Can you believe it? We are all the way to Unit 2 already, and today we are talking about fractions and decimals. Students will be able to convert fractions to decimals, both terminating and repeating. They will also be able to order and compare decimals and fractions. So let's start with those two vocabulary words, terminating and repeating. It says some fractions like 1/2 and 3/4 can be written as a decimal by dividing the numerator by the denominator. So 1/2 equals 1 divided by 2, and 3/4 equals 3 divided by 4. If the division ends or terminates when the remainder is 0, the decimal is a terminating decimal. Now, you may have heard terminate as in somebody getting fired from their job. They were terminated, meaning their job came to an end. You might have also heard of the Terminator, Arnold Schwarzenegger, who ended people. So terminating decimals are decimals that come to an end. So first we're going to look at 7/8, also read as 7 divided by 8, also read as 7 divided by, and the 8 goes on the outside. Notice it's kind of like the fraction has tipped over almost. 7 divided by 8. Now, the thing is, we know that 8 is too large to go into 7 even one whole time. And so what we're going to find here is that we're going to say it goes in 0 times, which is a problem. So in order to continue, we're actually just going to put a decimal point with some placeholder zeros after, because 7 or 7.0 or 7.00, they are all worth the same thing, 7. Just like $7 can be written $7. $7 can also be written 7.00, and it's still $7. We've done the same thing here. So 8 goes into 7 0 times. Now, because it goes in 0 times, we're going to bring that decimal point directly up and say, okay, well, if it goes into 7 0 times, what about 70? What if we tried to do 8 into 70? And we said, well, it definitely can go into 70, and it happens to go in 8 whole times. And 8 times 8 is 64. That's how I know it goes into 70, because 64 is less than 70. So I would put the 64 directly below and say, well, what's the difference? And that's why we subtract them. How far off is my 64 from the 70 that was on the page? And it's 6 off. So now we're going to say, okay, we're going to bring down that next 0 and say, well, 8 into 60. Well, it doesn't go in 8 times because that was 64. It only goes in 7 times. 7 times 8 is 56. And the difference is 4. I have 4 remaining. I'm going to keep going. I'm going to bring down that next 0. Now, these arrows do not need to be written. I'm writing them right now because we're practicing. The goal would be to not have to write them, but it does keep us organized in the beginning at least. How many times does 8 go into 40? And we go, oh, that's right. I remember that fact. It goes in exactly 5 times because 5 times 8 is exactly 40. And you have no difference left over. You also have no non-zero numbers, meaning there's not a 1, 2, 3, 4, 5, 6, 7, 8, or 9 back here waiting to be used up. So we would say that this answer has terminated. Our answer is 0.875, and it is terminating. All right, so that would be done. So let's look at 4/5. Same idea, 4/5, also 4 divided by 5, or we can write it as 4 divided by 5. And we all know 5 is not going to go into 4 evenly or at all because 5 is larger than 4. So we're going to do the same thing where we're going to put those placeholder zeros just like we can for money. So does 5 go into 4? And we all know that it's a no. And we're going to bring our decimal point up here into the answer because the answer is less than 1. 5 goes into 4 less than 1 whole time. 5 can go into 40, though, exactly 8 times. 8 times 5 is 40, and we get 0. Now, we got 0, which is great. Are there any non-zero numbers left back here? Any 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, or 9s? No, we can actually say that we're done at this point. We don't need to keep going if there's non-zeros, if there are no non-zero numbers left. So this one would be 0, 8, and we would also say it's terminating. Now, I understand that dividing decimals is review. For some of you, the new concept maybe would be just the vocabulary word terminating, that the answer does come to an end. Not all fractions can be written as terminating decimals. Sometimes a digit or group of digits repeats without an end in the quotient. Quotient, remember, meaning the answer to a division problem. So the next one that's here is 5/12, 5 divided by 12, or 5 divided by, and you'll notice the 12 is on the outside. And 12 is larger than 5, so it does not go into 5 a whole time. So we're going to do that same idea where we put some placeholder zeros here after the 5 and the decimal point. 12 went into 5 0 times, and we bring up our decimal point because we know that it's worth less than 1. 5/12 is worth less than 1 whole. This would be like saying I ate 5/12 of the pizza. Well, did you eat a whole pizza? No, I only ate 5/12, which is less than a whole. So our decimal needs to be less than 1 whole. 12 didn't go into 5, but does 12 go into 50? And we would say, yes, it goes in 4 times, but 4 times 12 is only 48. The difference is 2. Bring down the 0 for the next place value. 12 goes into 20 only once. 1 times 12 is 12. Can't go in twice because that would be too big, 24. 20 take away 12 is 8. Ooh, that's kind of big, but it's not bigger than 12, so I know we're okay. Bring down a 0. Does 12 go into 80? Yeah, it does. It goes in 6 whole times. 6 times 12 is 72. Now, if you didn't know that one, over here on the side of your paper, you might have tried 12 times 6. And it's 1 for the carry there, 2, 1, 2, 6 times 1, 6 plus the extra 1, 7. Oh, 72. Like you might have had to do the work over to the side, which is fine. 80 take away 72 leaves you a remainder of 8. I just had a remainder of 8. But it didn't terminate. So I'm going to go up here and I'm going to add another 0 because I didn't terminate yet. And I'm going to bring it down and say, does 12 go into 80? Yeah, it did just a second ago. It went in 6 times. I checked over here. 6 times 12 is 72 with a remainder of 8 again. So what I'm noticing is if I try to bring down another 0, I'm going to get another 8. This pattern is repeating. I got an 8, I brought down a 0, 72. I got an 8, brought down a 0, 72. I got an 8, brought down a 0. Since I only have zeros up here, nothing is going to change. This pattern, you will notice, is repeating. The answer has also started repeating. So when we write our answer, 0.41, and then notice it's the 6s that are repeating, we're going to put a little bar over the top. And that tells the other people reading our paper that it's 0.41 with the 6 repeating. And so we would say this is a repeating decimal. All right. And we've got another one on here. -2/11. Now, there is only one negative sign. I'm going to make a note for myself. Negative. The answer, the decimal, is also going to be negative. But when you do 2 over 12, 2 divided by 12, or, 2 over 11, 2 divided by 11, or 2 divided by 11, you will notice that I don't put the negative signs into my long division. It will only go in the answer. I have to make that note for myself so I don't forget. So does 11 go into 2? No. 11 is too large to go into 2. I bring my decimal point up there. I'm getting an answer smaller than 1. 2/11 is smaller than 1 whole, so our decimal should be smaller than 1 whole. 11 goes into 20 only 1 time. 1 times 11 is 11, and the difference is 9, which is good. It's smaller than 11. Bring down a 0. Does 11 go into 90? Sure it does. 8. I'm really good at my 11s. 8 times 11 is 88. And that's a remainder of 2. Hasn't terminated, hasn't repeated. I'm going to keep going. Bring down a 0. Does 11 go into 20? Sure, it goes once. 1 times 11 is 11 with a difference of 9. This is starting to look familiar. Bring down a 0. Does 11 go into 90? It does. It goes in 8 times. This is really starting to sound familiar. 8 times 11 is 88 with a remainder of 2. And then I notice that I've got this, and then it matches again here, and I'm starting again. The only thing I have to bring down are zeros, so this is also a repeating decimal. If you look up what's repeating, it almost sounds sing-songy when you say it out loud. 0.1818. Well, it's going to keep going. 1818. So the repeating is both the 1 and the 8. So the bar goes over both the 1 and the 8. And then I'm going to go, oh yeah, don't forget, it's negative 0.18 repeating. And so this is a repeating decimal. So we have terminating decimals, we have repeating decimals. We might also have negatives thrown in there. Not a big deal as long as we just sort of make ourselves a note. So repeating decimals have a pattern, and that pattern allows us to use bar notation. So what we're looking for is what's the thing repeating. So here, 0.166666, all the 6s are repeating. So we would say 0.1, and we only put the bar over the 6 because only the sixes are repeating. You can actually get that from 1/6. 1 divided by 6. So this is a kind of a weird one. And the reason I'm doing it out is because it actually happens to be one down here that we should memorize. 5/6 is on our list, and for some reason, I forgot 1/6. So 1/6 should be added in here, and we're going to do it out right now. 1 divided by 6. I know that 1/6 is worth less than a whole. So 6 goes into 1 0 times, less than 1 whole. 6 goes into 10 once. 1 times 6 is 6, with a difference of 4. Bring down a 0. 6 goes into 40 6 times, but not exactly, because 6 times 6 is 36, with a difference of 4. Bring down a 0. 6 goes into 40. I got a 40 again. 6 times 6 is 36 again. If I keep going with these zeros, I'm going to keep getting 40, 36, 40, 36. And that's what tells me that it is the sixes that are repeating. So down here, 1/6 is 0.16 with only the 6 repeating. 0.353535. That one you'll notice has that sing-song 353535. It's the 2 digits, 0.35, both repeating, so they both get the bar. You can also have numbers that are larger than 1 whole that happen to repeat. So this is 12 and there's your decimal point, 68888. So we put the 6, there's only one of it, but the 8s repeat, so the bar goes only over the 8. Now this is one of our unfriendly repeating digits, but if you notice 714285, 714285, the next digit's going to be a 7. So 5.714285, sometimes it goes a lot of digits before it repeats, and this one happens to go 6 digits before it repeats. All right, now there is a table here of fraction decimal equivalents, and some of them you should already know. You should already know by the start of 7th grade that 1/2 is 0.5. Most people have seen or heard that 1/3 is 0.3 repeating, not just 0.3, 0.3 repeating. And if 1/3 is 0.3 repeating, then 2/3 is 0.6 repeating. Those are usually ones that people are familiar with, along with 1/4, also known as 1/4. Think of the value of a quarter being 25 cents. 3/4 being the value of 75 cents. Those are usually the ones that most students come in already knowing. Then you've got sort of the middle fractions, the ones that are like some kids know them and some kids don't. That's the 1/5, 2/5. Somewhere on here I should have 3/5, and I should have 4/5. Each fifth is worth 20% or 0.22 Those are all kind of in a group, 0.2, 0.4, 0.6, 0.8. If you guys have ever counted 2, 4, 6, 8, those are your fifths. The other one that a lot of people come in already knowing are your tenths and your hundredths, 0.1 and 0.01. Now, the ones that people are usually quick to learn, but don't know them when they get here, are the ninths. 1/9 is 0.1 repeating. Notice it's 1/9 and it's a 1 repeating. 2/9 is 0.2 repeating. Okay, so it's 2 in the numerator, 2 is repeating. 3/9 you'll notice isn't on here because it's equal to 1/3. 4/9, it's a 9th and it's a 4 repeating. 5/9 has a 5 in the numerator with a 5 repeating. 6/9 is not on here because it's equal to 2/3. 7/9, 0.7 repeating, and 8/9, 0.8 repeating. Those people pick up pretty quickly. The ones that tend to be the trickiest are the sixths. People don't usually know those off the top of their head, have to spend a little bit more time on them because you are expected to memorize the ones that are on this table. You should be able to know these off the top of your head. If you don't already, flashcards are awesome. Compare fractions and decimals. So this is the next step. What if one is a fraction and one is a decimal? Well, the best thing to do is convert them both into the same. And since fractions can have all kinds of crazy denominators, and decimals are always based on tenths, hundredths, the easiest way is to convert your fractions into decimals. Now, 1/4, right here in our table, it's our memorized 0.25 compared to 0.2. Never compare decimals unless they have the same number of digits. So 0.25 0.2, if there's nothing there, put a 0. I'm comparing 25 hundredths to 20 hundredths. Which one is larger? The 1/4, the 25 hundredths. So I put the big part of the sign, the big open part. Some of you learned when you were really little about an alligator eating the bigger number. That's going to go over to the 1/4 because that number is worth more than the 0.2. We do also know from up here at the table that 0.2 is worth 1/5. You'd have to know that 1/4 is larger than 1/5, but you could convert them both to decimal, both to fractions if you wanted. 1/4 also greater than 1/5. So as long as you're comparing things that are similar, or you've heard the word maybe comparable. Okay. So now we've got negatives. We have to remember when we're comparing negatives, the one closer to 0 is the bigger one. And right now I've got something in eighths and something in ninths. That is not very friendly. So I'm going to do 5/8 and figure out what that's worth. So I put my decimal point in my zeros. 8 goes into 50, not 5. So I'm going to put in my 0 there and say, nope, it's less than 1 whole. Goes in 6 times 8, which is 48, and a difference of 2. Bring down a 0. 8 goes into 20 2 times, and 2 times 8 is 16 with a difference of 4. Bring down a 0. 8 goes into 45 times, and because it goes in exactly, that would be a terminating decimal 0.625. Now remember, it's negative. So I'm comparing negative 0.625 to the 6/9, which is awesome. We just learned a trick about the ninths. Well, right here in between 5/9 and 7/9 would be 6/9 or 0.6 repeating. So I know that this is negative 0.6 repeating, which, again, I said, never compare them if they don't have the same number of digits. This would be negative 0.666. Now, which one's closer to 0? The one that previously would have looked smaller, 625 hundredths, is going to be closer to 0 than 666 hundredths because they're negative. So the larger one is the one that's closer to 0, the 625. So the 5/8 that is negative, closer to 0 than the 6/9 that is negative. When they are both negative, we're looking for the number that is closer to 0. Last but not least, 6/7. I don't know that one off the top of my head, but I do know that I'm comparing it to 0.87. So I only have to go far enough to say, is it bigger than 0.87 or is it smaller than 0.87? And that's a really great skill to know. So I'm going to put some zeros on there after the decimal point and see what I get. Does 7 go into 6? Nope. 7 is larger. So I'm going to say doesn't, but I can check 60. 7 goes into 60 8 times because 8 times 7 is 56. And the difference is 4. This one starts with 0.8 and this one starts with 0.8. So I'm not done yet. I'm going to bring down that 0 and say 70 goes into 40 5 times. 5 times 7 is 35. And I'm going to subtract and get 5. And now I'm comparing 0.87 with something that starts 0.85. It doesn't actually matter what comes after that. If I'm comparing something that starts 0.85 with something that's 0.87, I already know that the 0.87 is larger and I can stop. Please do not keep doing the division until it terminates or until it repeats if you can answer it after 2 digits. Okay, so hopefully you come to me with any questions that you have about this, but I'd love to think that this is a majority review, except maybe a couple of those fraction decimals from the table and maybe the idea of comparing negatives. So I'll see you in class.